Hello and welcome back to another episode of InstaBlinks. And I'm here today with Ahmed Khaldi, who is a solution architect for Apache Spark at Instaclustr by NetApp. Ahmed, go ahead and give us a little introduction.
Hey, Brian. Thanks for having me here. So I'm Ahmed Khaldi. As you said, a solutions architect now for Instaclustr by NetApp. I'm officially focused on Apache Spark. That's my background as a data engineer. I worked in multiple financial institutions, mainly focusing on Apache Spark, but with other open source technologies like HBase, Cassandra, Kafka. So today I'll be talking a little bit about Ocean for Apache Spark and Kubernetes, and these sorts of things.
Awesome. So last episode, I had on Hisham Kanish to talk about Ocean for Apache Spark a little bit as well, and Apache Spark 4.0 when that comes out. Can you give us just a quick rundown for people that maybe didn't see the last episode? What is Ocean for Apache Spark?
Yes, of course. So Ocean for Apache Spark is a platform that lets you run your own Apache Spark workloads without any need to get the infrastructure set up or any DevOps work. So effectively, it's a serverless Apache Spark. Now, all you need to focus on, your data engineers will need to focus on developing the code, and we even help optimizing that part. So effectively, we prepare all of the infrastructure, all of the work for you to become as much productive as can be.
Awesome. So then talking about Apache Spark and Kubernetes, right? We'll dive into more use cases and things around this, but can you maybe tell us why Apache Spark for Kubernetes compared to maybe other traditional deployments of Apache Spark?
Definitely. So the idea, as I didn't say before, but we run Apache Spark on top of a Kubernetes platform. And we chose that because today Kubernetes is the standard of today's microservice technologies and etc. But even in Apache Spark, it has huge benefits. So we have seen some studies that show running Spark on virtual machines and running Spark on Kubernetes, we have seen increase in performance, increase in cost reduction, not increase. And we have seen lots of other benefits, which we can easily use spot instances, for example, interruptible instances in Google. That's the main idea behind running Spark on Kubernetes. Now, Ocean for Apache Spark, we add a layer on top of that, which is I would say a user interface, a good user interface for a developer to be able to actually debug applications much easier, optimize applications. That's the hardest part in running Apache Spark, is optimizing the application. So yes, that's why we run Apache Spark and Kubernetes.
So if we kind of dive in a little more into the deeper technical side of this, correct me if I'm wrong, right? So the Spark driver runs as a Kubernetes pod?
Yes. So the classic architecture of an Apache Spark application is you have a master node that you have a resource manager. That the resource manager will get you the virtual machines, will get you the resources to run your Spark applications, which run in parallel. That means in each application, you have a driver, which is the master, and then you have workers that do the actual work. So in a Kubernetes world, that would make it you have a driver, that the master, which would be a pod instead of an entire virtual machine or entire process. And you would have pods that represent the executors. These driver executors, since it's Kubernetes, they will be in parallel. They can be in different machines. They just need to be inside the same cluster. And that's what Spark and Kubernetes will work. Our philosophy behind this is, since Spark is actually elastic by nature, we can afford to lose these workers. If we lose a worker, it doesn't really affect the workload. We will continue to work and we will reschedule another worker. We put every driver, we put it on an on-demand or savings plan instance, an instance that we are sure we won't lose. And then the workers, the executors, we will put them into spot instances. And that's our philosophy behind it, is to actually save you as much money as we can.
That's awesome. So if we look at Spark on Kubernetes versus Spark on virtual machines, Spark has the ability to interact with the Kubernetes API, right? And do requests and releases of resources, whereas maybe with a virtual machine, more of that was possibly manual, or is that kind of the idea?
So in the previous world, today's world still, in virtual machines, we have what we call Yarn. That's the de facto resource manager. In Kubernetes, it works a little bit different. Same principle. We have an operator that will, a Spark operator, we call it. It's an open source project by Google. A Spark operator that it will handle this part of communication between the Kubernetes API and the driver executor allocation. That's the key component here. So every Ocean4 Spark cluster will have this key component, which we call Spark operator. Now, of course, we not only have this, we have lots of things like the notebook operator, for example, which helps you run notebooks, so interactively run your Apache Spark. So you could query some data, you could do some testing. We also have log collection, an ingress connection to have the live features, so streaming the log live, you seeing Spark UI live, these sorts of things. But the main component is a Spark operator.
Awesome. Yeah, I love going a little bit deeper than the superficial questions that we normally do. So thank you. Maybe we can pivot a little bit, and you can talk a little bit about some of our customers. What are you seeing with Spark on Kubernetes with any of our customers that you can talk about?
Definitely. So we have seen, at least in a couple of customers, where we just lift and shift an existing Spark environment from virtual machine to Kubernetes. We have seen them running from either do-it-yourself Spark, so they set up everything from scratch, resource manager, everything they set up on themselves, or they went from a vendor that was using virtual machines. In both of these cases, we didn't change the type of the instances. That means we went from an on-demand instance to an on-demand instance. We just changed the fact that they run on virtual machines and then on Kubernetes. In both of these cases, we have seen respectively 30 and 40% savings in terms of compute. This is still, as I said, without any change of the instance types. The first customer went from on-demand to on-demand. The second one went from spot to spot instances. So I would say this actually, we have seen some studies, etc., but this is a real-world scenario where we have seen customers appreciating this.
Okay, maybe can you talk a little bit about the United Nations and what they're doing with Apache Spark?
Yeah, that's a great point. Actually, so for the United Nations, we have published a use case. It's available on our website. So for the United Nations, what we did effectively, so the first thing that's super interesting is that we actually managed to save them 70% of their previous cost. We did that with various techniques. So the first one is, of course, we are running on top of Kubernetes. That brings the cost down. Second part is we changed the type of the nodes. So they were running on demand. We managed to make them run on spot. And the most important thing here is they have a population of data scientists. These people need to interactively run the code. So they run mostly on notebooks. The problem with notebooks is you open a notebook in the morning at 8 a.m. when you arrive. You spend the day developing, but you either go get a coffee, you go to Stack Overflow, ChatGPT, whatever technology, but effectively you are coding maybe 1 or 2 hours a day. And the other part is you are debugging, you are asking questions, you are documenting. And the classic word is you arrive at 8 a.m., you have 32 cores, 128 gigabyte, and then you reserve that for the entire day. And you don't actually use it. So with dynamic allocation with Spark and Kubernetes, we actually managed to, if you're not using anything, then the executors, the workers, will scale down. So you'll only have the driver that's alive. The driver is usually very small, like 1 or 2 cores. And you leave the application alive, but you don't have any sort of workers. Once you run a command, the workers will scale up. So it will take a couple of minutes or 3 minutes, and then the workers will come up. And that's how you actually follow the trend of your data scientist population. And that's what made them gain the most from cost perspective, at least.
So maybe we can up level a little bit here and talk a little bit about how Apache Spark integrates with other open source software technologies. Are we seeing customers integrating Spark with other technologies like, for example, Kafka or Cassandra?
Definitely. So I would say most of our customers do. So Apache Spark is, I would say, just is there to transform or do an extraction of the data. That's all it does. So it needs a source of the data like Kafka in a streaming platform. Or in a batch platform, we would need some sort of database or landing area like S3 or some sort of object storage. Spark, I would say, will work from there. So it needs some sort of data. And then it needs also to dump its data somewhere. So either a classic database or a big data database like Cassandra, HBase. It's actually a Swiss knife. You can actually use it with any other tool. The integrations are rather easy. This is a Java code at the end of the day. So every integration is a jar that you need to put somewhere and do the connection. Classic workloads today with Apache Spark, we have what we call the storage technologies like Apache Hudi, Delta Lake, Iceberg. Usually Apache Spark will save files in those formats. And before that, we either have Kafka or we have a landing zone like S3, as I said, or any object storage. That's how we see them today.
Okay, great. So because it's 2024, I do have to ask about integrations with AI or large language models. What are we seeing with Spark and AI in 2024?
Definitely. So my take on this is so AI, machine learning, data science, and artificial intelligence has been around for a long, long time now. And every time there is a hype around this, and we forget about the importance of cleaning the data, of having the right data to train our models. And I firmly believe that that's one of the most important steps to have a good predictive model. So Spark actually will work on that part. Now, when I say it will work on that part, it will do the cleaning, it will do the transformation, it will handle all of the data pre-AI. Now, if we want to take it a step further and integrate Spark with the AI training and real machine learning real machine learning stuff, actually Spark there is a native integration with pandas, with any other Python dependency that you would like to actually use to train your models. Spark will integrate with that natively because you can actually write Spark with Python. You can also write Spark with Scala. So if you have any Java or Scala application that you need to integrate with, you can actually do that.
Okay, that's cool. Let's see. I think I have one more question for you, and it goes back to one of the first things that you talked about in this interview when you were talking about some of the complexities of setting things up. For individuals, the technology can be somewhat complex. So what are some of the best practices for monitoring and debugging Spark on Kubernetes?
Of course. So when running Apache Spark, I would say one of the most complicated things is to actually set up a good environment for the developers to debug, because you don't only need logs. The logs can come from 3 different parts. You have the infrastructure, you have the driver, which is the application logs. But sometimes you also have these workers can have some trouble, and you need those executor logs. So you actually need to think of the 3 parts here. This is something that we actually do. We provide Kubernetes events, we provide application logs, and we provide executor logs. Each time we either stream them or make them available for download afterwards. This is the first layer. So just getting to know the error and finding the error. Now, the other part that is less obvious is sometimes you don't have any issues, but your job actually runs in 4 hours and costs you $100. And you know that for a fact that it should cost you half that or something like that. So in order to see that in a classic Spark, you have to go into Spark UI and check some very technical things that are so not easy to do. I speak from experience here. And so what we did, at least in order for Apache Spark, is we took that same file that creates the Spark UI, which is called Spark event logs. So every application's events, this is what the file does. And we created some sort of graphics around CPU usage, memory usage, data read, data written, partitions, these sorts of things. So that way, without the need of doing anything, you just go into the UI, you will see if you have over-provisioned your CPU, if you didn't provision enough memory or CPU, and in a couple of seconds, you know that you need to scale your application down to a half or double it down or optimize your applications.
Awesome. So for anyone that wants to try Ocean for Apache Spark out, where can they go?
So today we are still in even though we are Instaclustr by NetApp, we are still in the Spot console, Spot by NetApp. So Spot by NetApp is another acquisition of NetApp. So we need to go to Spot by NetApp. There is blogs on how to get started, on contact us for a demo. We can also do it by yourself. You just need to connect to the console, create an account, and then connect your AWS, Azure, or Google account, and then do the work from there. It shouldn't take more than, I would say, one hour to get everything ready, because you have a Terraform script that sets it up. You create an EKS cluster, import it to Ocean for Apache Spark, and then you should be ready to start testing.
Awesome. Ahmed, thank you so much for taking the time to talk with me about Spark and Kubernetes, Ocean for Apache Spark. For everyone that is watching us, thank you for joining us, and we will see you on our next episode of InstaBlinks. Have a great day.